This video covers examples of intersection between a line and a plane. So in 3 dimensions, there are 3 possibilities. The first one is here, where the line is parallel to the plane. Here is the second one, where the line intersects the plane. And here's the third option, where the line lies on the plane. So really we can have 0 points of intersection, 1 point of intersection, or an infinite amount of points of intersection. So the first example that we're going to do is to find the intersection of the line with parametric equations x, y, z here, and the plane whose scalar equation is 4x minus 2y plus z minus 19 equals 0. So first we want to describe any point on the line. So we can do that by knowing that any point is going to have an x, y, and z coordinate, and our x, y, z coordinates are given by our parametric equations. Plus 2t. So this point will lie on the plane if for some particular value of t, particular value of t, these coordinates satisfy the equation of the plane. So we're going to take our x, y, z coordinates and we're going to substitute them in to our equation of the plane. So I'm going to take my x and substitute it in here. And then I'm going to take my y, substitute it in here. And then finally, I'm going to take my z and substitute it in here. Minus 5 plus 2t. So all I'm doing is taking my parametric equation of the line and substituting it into my scalar equation of the plane. So expanding, simplifying, and collecting like terms, you should end up with 4t minus 8 equals 0, and then t equals 2. So because we get a solution for t, this means that the point on the line with the parameter t equals 2 is the point at which the line intersects the plane. So we can find that point by subbing in t equals 2 to our parametric equations. So x, y, and z. Which is going to give us 5 for x, 0 for y, and then minus 1 for z. So that means that my point of intersection is the point 5, 0, minus 1. So let's move on to our next example. Now we have a line and a plane, and we're going to check and see if we can find a point of intersection, if any exist. So let's try the same thing again. So we're going to start with any point on the line, x, y, and z. So we know that our x would be 3 plus s. Our y would be 1 minus 4s. And then our z would be 2 plus 8s. So this is just taking each of the components from our vector equation. If you'd like, you can write it in parametric form first, as the first example was. So now we're going to sub our x, y, z into the plane. So same thing here. We've got 4 times our x, which is here, 3 plus s, plus 2 times y, which is here, 1 minus 4s. And then we've got minus z, 2 plus 8s. And then our d term here, minus 8 equals 0. Expanding, collecting like terms should give you minus 12s plus 4 equals 0, which means that s equals 1/3. So therefore, our point of intersection exists, and it is at s equals 1/3. So in order to find that point, we'll do sort of a shortcut here. We're going to substitute in our parameter, s equals 1/3, into our any point on the line. And we're just going to substitute in that 1/3 for s. Okay, and when you collect all those terms, you get 10/3 minus 1/3 and 14/3. And then this would be our point of intersection for this particular line and this plane. So let's do one more example. So here we're going to find the intersection of the line and the plane if an intersection exists. So here, again, we're going to start off by writing an expression for any point on the line. And so we're given our parametric equation, so that's nice and easy for us. Putting in our x, y, and z. And now we're going to sub in to the equation of the plane. So here we've got our equation of the plane. So x, I think I started with x being red. So we've got 2t from up here. Then we've got plus 4 times y, 1 minus t here. Then we've got plus 2 z, so minus 4 plus t. And again, we're trying to solve for an to see if there's a value for t that satisfies the equation. So here we've got minus 4 equals 0. Collecting all those like terms is going to give you the equation 0t equals 8. There is no value that satisfies this equation. So therefore, there is no point of intersection, which means that the line is parallel to the plane, because that's the only way not to have a point of intersection. The last 3 examples I'll do in the next video.